what is formula. Correct? Okay? The most critical part is how you determine these two values. Okay? Okay. Then substitute the value back to this equation. And now, okay, I can calculate S1 squared. So 7.8182 squared divided by 6.062, okay, square times what? 0.2857. Okay. So here is the ratio of variance. Okay, and then here will be, okay, 7.8182 squared divided by 6.6. Okay, 6.062 squared. So this one is 3.7250. So from here, you should be able to get the interval value. So what is the interval? 0.4752. Here will be 6.2031. So this is how you get the ratio. Okay, C. Determine the answer in B. Okay, determine whether the two variants are equal. Justify your result. Is that equal? Yes. Why? Because includes one. That's all. Okay, how to answer C? Okay, so C. Okay, determine if two variants are equal. Yes. The answer is yes. What is the justification? Okay, because this ratio includes one. Okay? Okay, so this is one. So, okay, now. Okay, claims. Okay, claims. Okay, the mean diffraction for type 1 is greater than type 2. Proving means that hypothesis testing up. This is second part of the question. How should we do it? Okay, so we want to prove the claims means that we must perform hypothesis testing. We want to prove the mean type 1 is greater than type 2. This is the requirement from this question. Okay, so in this case, greater than mu1 is greater than mu2. Hence, the null hypothesis always equal. Always equals answer. Okay, right? Then, can you tell me that this involves two populations? We are required to find the mean. Again, this is case 1, 2, 3, 4, or 5. Yeah, this one here. So, which one? What? 2?
4.
Yes, 4. Okay, exactly the same in the question. Okay, what is the reason? Because population variance are not even, and then the number of sample, okay, is small. Okay, and then the assumption is equals to 1. Because why? Because we already define, okay, it is equals includes 1 minus mu2 equals to 1 unless it is written. Okay? If it is not equal or equal, mu1 minus mu2 is equal to 0. Hence from this equation, okay? So mu1 minus mu2 is equal to 0 from this part. Okay? So you have x bar 1 minus x bar 2. You know what is n1 and n2, right now? Okay, so this is very straightforward. You just need to find out what is SP by using the formula SP. Okay? I will not write down the formula already, so I will write only the answer. So apply the formula, you should be able to get the SP as 6.9372 SP. Then you will get substitute to the equation. You should get the t-test, which is equal to 1.6687. Okay? So with this, we complete the t-test. Okay, you are required to find the equation please. Okay, then t-test, you should get 1.668. Okay, we complete the step.
뭐? SP.
T-test. So, t-test. And then, step number 3, you have to compare, okay, with T critical, okay, T critical value. So, how to write the critical value? It is written as, okay, depends on the alternative hypothesis. Alternative hypothesis more than means one-sided, upper one-sided. Okay? Okay, we have two-sided, okay, lower one-sided, upper one-sided. Since the alternative hypothesis is greater than, hence, okay, the t-test is just like normal distribution. Okay, so you should know we just consider one-sided. Why? Because we know that the alpha no need to divided by 2 in this case. Okay, so it is written in this form. T alpha, then degree of freedom is in the form of n1 plus n2 minus 2. So this critical value is 0.05, then 8 plus 9 minus 2 will give you 15. Okay, so what is the value that you can obtain from the table? So, okay, so this is the rejection zone. Okay. Okay. So, here is the acceptance zone. With this is the critical value. What is the critical value? 1.75. Okay, 1.75. Then we compare with our t-test. T-test is 1.6, very close to it. Okay, 1.6. Okay, so this is our t-test. Okay, this is 1.6. Okay, from here we know that we can make a decision. Okay, fail to reject. Okay, fail to reject null hypothesis. If we fail to reject null hypothesis, so in the conclusion, okay, we have to rewrite the null hypothesis. In this case, mu1 is equals to mu. Okay, we don't have enough evidence to support the claim. Okay, the type 1 is greater than type 2. Because from the conclusion, we just can make that, okay, they are the same. They are the same. Question 4. A study is conducted to determine the failure of the electronics component. So they are using 100 electronics components. Okay, and then the data is recorded. Based on this 100 observation, they ask you, is a Poisson distribution with a mean of 2? Okay, an appropriate model. So they ask you if the data follow Poisson distribution, okay, with the mean which is equal to 2 or not. So this question is related to 4 and goodness of fit test. Okay, goodness of fit test. So chi-square goodness of fit test. Okay, we're using the level of significance which is equal to 0.01. This question is not difficult, okay, because we don't involve that you need to confine the estimated value, and then there is no estimated parameter as well. You just need to memorize the step for the goodness of fit test. Okay, so for those who really pay attention for your assignment, actually this is 3 marks for you. Right now, because this is exactly the same with your assignment. Okay, for your assignment you need to do this. Okay, actually from the assignment you are very familiar with the goodness of this fit test rate. So for this question, this type of question actually is the bonus, okay, for the examination. But I'm not sure that I cannot tell. Yeah, cannot tell that in this, yes, okay, will come up. So this is not now. Okay, just that this is a passive question. Okay, so this is related to the goodness of the test. It is not. Okay, alright. Okay, so let's perform this. Just follow the standard procedure. Okay, so I do not write the full. Okay, just data follows. Okay, the Poisson, okay, distribution. You cannot write like this lah. With, okay, mean, okay, lambda is equal to 2, mean equals to 2. Okay, follow this. You cannot write in this during the examination. Okay, this is for the discussion. Okay, the data, okay, do not follow. Okay, then you repeat the same step. This is step number 1. Okay, the data follow Poisson distribution if lambda is which is equal to 2. The data do not follow the Poisson distribution which is equal to 2. Okay, so this step 1 very easy. Step 2, okay, do you remember that at the end you need to find the OI minus EI squared divided by EI? What is OI? What is OI? Offset value. Okay, so all these values that provided in the data is the offset value. SPE is estimated. Okay, so you have to calculate the estimated value. Okay, so for the chi-square test, you need to take another table to find out what is the OI minus EI squared divided by E. Then sum up the value only you can get the chi-square test. Then if you have forgotten about the step, always refer back to the book. Okay. Okay, so what should we do? Okay, copy this diagram. Okay, so the first one is the number, okay, of the effects. Follow the diagram. Okay, so we have 1, 2, 3. Okay, we have 0, 1, 2, 3, and then they tell you that it is greater than 4. Right? Okay, right. Then OI. OI means that the value that you get from the table, okay, which is 11, 29, 26, etc. We are calculate using the Poisson distribution because we want to test if this is follow Poisson distribution. Okay, in this case, what should we do? Get exponential negative lambda, negative 2. Okay, then times 2. Okay, x is equals to 0 divided by 0 factorial. This is how you calculate the probability. In this case, we get the px is equals to 0.1312. Okay, then choose another one. So how to calculate this? Exponential negative 2. Why 2? Because it's even. Okay, times 2 to power of 1, then divided by 1 factorial. Okay, with this you should be able to get 0.2707. Okay, from here you will get, okay, I will write the answer here. So you will get 0.2707. Okay, so from here you will get 0.1804. Okay, but don't forget about the last row. Okay, so you cannot use x is equals to 4 because it is more than. Okay, so what you need to do, you have to use 1 minus, okay, summation, okay, for the p x which is less than or equals to 3. Okay, so from here you should be able to get 0.14, okay, to 9 because when you sum up this, it should give you 1. Then after that, we are able to calculate the estimated value, okay, which is equals to n times the corresponding x is equals to I. What is this mean? So for example, okay, n is, from this we have 100 observation. Every single value will times 100. So in this case, we will get 13.53. Okay, so 27.07. Okay, 27.07. Okay, then from here, 18.04. The last one, 14.29. Okay, so you must remember this that whenever if you look at the DI, make sure that they are all greater than 5. If not, you have to repeat one more step. You need to combine the category. But for this, you no need. Okay, because all the value greater than 5. Okay, so the last step, we need to use this formula and then only apply OI minus from the question. Then K is referred to how many category. In this case, we have 5 category. Okay, how many row you have? Then minus P. P is the estimated value. In this case, you are not required to find the mean because they tell you the Poisson ratio with the mean of 2. Okay, it is given. Okay, you don't need to find the mean by yourself. Hence, in this case, we do not have the estimated value. Hence, it's 0 minus 1. Okay, meaning that you just need to find from the table what is 0.01 and 4. So, with this, you will get 30.277 as your chi-square critical. So, chi-square, you have to understand chi-square, the graph will be something like this. It's not normal. Okay, everything will be positive value because it is the square. Okay, so chi-square. Okay, so in this case, it is always the same method like this. Okay, so here we take acceptance zone and okay, so we have the rejection zone as like this. Okay, so this is referred to the chi-square critical, which will give you 13.277. Okay, so from the question, we know that the critical value is just 3 point something. Okay, so this is the chi-square test, which is obtained as okay 3.90